Okay, so now we're looking at volume of prisms, and just to remind you again, prisms are three-dimensional shapes with a constant cross-sectional area. So cross-sectional just means if you made a cut, that's the area of the cross-section. So in these shapes, let's have a look at why they have a constant cross-section. So a cube, okay, that shape there is constant all the way from front to back. Okay, the cuboid or the rectangular prism, any one of these faces, but I'll just do the first face, that face there is constant all the way from front to back. You could say the same for that face from the left to the right. Now in the cylinder, the face that doesn't change, the cross-section, is the circle at the top. The circle at the top is the same as the circle at the bottom. With the triangular prism, the triangle is the constant. Okay, triangle is constant from front to back. The rectangles, these rectangles are not constant. Okay, you don't have rectangles all the way through. With the miscellaneous, okay, even if you had a funny shape, okay, this area here, which you can't find mathematically, you'd have to be given it, but that shape at the top is all the way from front to top to bottom. Okay, so you wouldn't have a shape like that where you'd have to put numbers into a formula, you'd have to be given that. And with the composite, the shape that doesn't change is this L shape. Okay, so that shape there is constant from front to back. Okay, so in the last one, the composite, you'd break it up into different shapes. Okay, so let's have a look at some formulas. Okay, so there is a general formula that you apply to all of these shapes, and the formula is the volume is the cross-sectional area times the length of the prism. Okay, so whatever the cross-sectional area is, you times it by the length. But with some of them, we have some easy formulas. So the cube is just length times length times length. Okay, that is the area of the cross-section, length times length. So we have length times length times length is length cubed. With the cuboid, that is the area. That doesn't change, and we're multiplying by how long it goes. Okay, but in here it's just L times W times H. With the cylinder, pi, this is pi r squared, which is the area of the circle, and we're timesing by how long it goes. Okay, and with the triangular prism, half base times height, that's the area of the triangle. So each of these formulas has an area and timesing by how long it goes. So copy those formulas down, okay, including the top one, area times length. Copy them down, then move across and look at some examples. Okay, so we're looking at some examples of some simple shapes, and on the next page we'll have the harder ones. Okay, so in the first one, the volume is 2 length times length times length, 2 times 2 times 2, which is 8. Now the units are centimetres, and volume is a cubic unit. Okay. With the next one, volume equals length times width times height. So that gives us 24, and it's centimetres cubed. Now in this next one of the numbers is not needed. So if you have a look at the right angle here, so that's the height and that's the base. Where they meet at a right angle, one's the base and one's the height. So this number here, you don't use for the volume. You'd use it for the surface area, but you wouldn't use it for the volume. So the volume is a half times the base times the height times the length. So the 5 is not used. So half of 4 is 2, 2 3s are 6, 6 6s are 36, and we're in centimetres cubed. Okay. Okay, so I just had a slight pause. I had to go and get my calculator again. Come on. Okay, so the next one, the cylinder, we've got volume equals pi times the radius. Now the radius is not 8, the radius is 4. So it's radius times the height. So we have 160, 4 times 4 times 10 is 160 times pi, clear, sorry, calculator again. And that is 502.7 to 1 decimal place. 502.65, 502.7 meters cubed. Okay, so copy those down and come across when you're ready. Okay, so now we've got some composite shapes. So just to remind you what the area is. Okay, so the area is, that is the shape that doesn't change. Okay, so we have to find the area of that shape there. Okay, so what I'm going to do is I'm going to divide it into two shapes. So that's one shape and that's the other shape, and we're going to find the area, and then we're just going to times the area by the length of the prism, which is 3. Okay, so what I'm going to do is I'm going to just transfer this number. So that 2 there can come across, that 2 there can come down. So the area of shape 1, which is a square, it's 2 by 2, which is 4. Now, in area 2, we've got to put some numbers. So the total is 8, that's 2, so that means that that's 6, which means that that's 6. That number's 2, the total's 6. Actually, I don't need that. I just need to use a 6. So area 2, I don't need to worry about breaking it up. Area 2 is 6 by 6, which is a bigger square. So the total area is 40. And the volume is the area times the length, so it's 40 times 3, which is 120 centimeters cubed. Okay, now in the next one, it's like, that's the shape that doesn't change. And what's that shape called? It's called a half of a circle. Okay, so the area is a half of a circle, and a circle is pi times radius squared. Now the diameter is 10, okay, so half of that is 5. So we've got 12.5 times by pi, clear, made a mistake, sorry guys, 12.5 times pi, so it's 39.3 to 1 decimal place, centimeters squared, and then the volume is the area times the length, so it's 39.3, and the length is 5. So the answer is 190. I'll just check that again. 39.3. 196.5, and we're in centimeters cubed for volume. Okay, so cubic units for volume, square units for area. Okay, I think that's my last example. Okay, so in the bookwork, Maths Quest 10, exercise 10E, just have a go at those questions. They're the ones that have constant cross-section. Don't worry about any of the other ones in that exercise that don't have it, because that's the 10A content. Okay, thanks. Bye.